really simple. We're going to go over the syllabus for a little bit. We are going to spend a little bit of time doing a group activity and keep it easy and pretty breezy. Cool. Any questions? Great. Cool. So I'm going to pull up our syllabus. Big. Um, these.
Actually, it's not your She is so very. She's so.
Cool. So, syllabus for this. I would super appreciate it if you could at least put your name on this because this syllabus is yours. It's got a lot of really good information in it. I spent a lot of time trying to work through it. So please bring this to class pretty much every day. There will be a lot of times that you will just pull it out for quick references and stuff like that. Yeah. So if we open it up to the first page, it's got all the general standard info, when this class is, where it is. You've got my student hours over here, which is just my office hours where you can just come in, hang out with me, ask me questions about the book and stuff like that, whatever is going on. We also have a teaching assistant, Ananda Kincaid, who has met Ananda. Great. I was supposed to make this as a slide. I didn't do that fast enough because I wanted to eat lunch. So, here is a picture of our lovely TA. So when you find out who Ananda is, Ananda's mostly not going to be showing up in class. It is going to be dedicated office hours outside of class for you to go and ask her a whole bunch of questions about the class. You can do your homework with Ananda. You can, yeah, she's going to help set up some of the experiments in the background and also help me with grading some stuff and just like making sure that everyone's keeping up on their progress and things like that. But Ananda is going to be an invaluable resource. Super awesome chemist, great student. Yeah. For what?
What?
You said sorry.
Oh, my Velcro's really
Oh,
loud.
you're good. No worries. You're good. Cool. The textbook. We are going to be using this 10th edition of General Chemistry by Whitten, Davis, and a whole bunch of other people. This is a older textbook because chemistry really hasn't changed that much, but it's also an older textbook because it is really valuable for you to have a physical copy of this textbook with you. You can just like leave it at your dorm or wherever you're like staying when you want to use it. You don't have to bring it to class explicitly, but it is really good because there's a lot of times that we're going to be working problems from the textbook. Not everything that we cover, like I might give you a couple of homework problems that are going to be stretching things that we didn't always cover as well in class. So you might want to actually read through the textbook at times and skim through it. Because it's an older textbook, you can find it online for like $10 to $20. So you can get this pretty cheap. It is a really solid textbook. And Rand uses it as well for Gen Chem 2, which I think I'm teaching Gen Chem 2 next year. So if you want it, it is worthwhile investment, at least for that part. If you were to go to our class Moodle page, go over here. You can also find a link to the textbook online. So you can just download it as well if you want to have a digital copy. So this one's really good to keep at home. Digital copy, really good to keep when you're coming to class and you have like other little questions because it is pretty heavy. A lot to lug around and stuff like that. Any questions? Great, cool. Evaluation criteria. So I pretty much use a pretty standardized like evaluation criteria throughout all my classes at this point because it worked really well last year. So essentially, I will write at the end of the semester 2 to 3 paragraphs about your performance in this class and how well you really did in all these different things. But most of the people who read your evaluations at other institutions, they're not going to read all of these paragraphs about all of your classes. They're going to skim through it. So for my evaluations, you get to sort of craft, based on your performance, the first sentence that would be on your evaluation. So it is going to look something similar to name is an overall effort, student who attendance, something about your completion of assignments, and blank on their knowledge. And you get to fill in the blanks based on how much you come to class, engage with the material, how well you seem to know the material, all these things. So an example would be Julie is a phenomenal student who usually attends class. Hopefully I can do better. Successfully completed all their assignments and truly demonstrate their skill of the subject. So based on how well you fit into these categories, whether you were sick a lot and didn't give me excused absences, please just send me an email if you're not going to be here, just so that I have some record that like as to why you dropped off the face of the earth. If you complete all of your assignments, there's going to be pretty much a requirement that you do pretty much all the major assignments, but if you miss a couple of the small homeworks and stuff like that, not a big deal. You can still get a really good, phenomenal evaluation. And a little bit about how well do you seem to actually grasp the knowledge and the concepts that we're doing in class. Any questions about this? Cool. So general summary about things. I always ask that you try to take care about your need, you yourself and all of your needs. If you need to get up and use the restroom or stretch or something like that, bathrooms are down that way. Dog is in my office. If you need an emotional support animal, she is here for you. Be polite, respectful. I strongly encourage you to work together in groups. Like when I tell you information for one time, it is just going to be me trying my best to convey it, but the way that I convey information might not be the best way for you to always hear it and register. So when someone else gets to explain it to you, that might really help you reinforce that subject and get it a little bit better. So when you and your friends are actually talking and working together, you're helping each other quite well actually learn these concepts. You are allowed to use AI for some things in this course if you need to, but you need to ultimately be responsible for the information. AI can be really good at helping you understand a problem set, especially in the homeworks and things like that. But I need you to be able to show up in class later on and actually demonstrate that you did, in fact, learn it. It didn't just tell you the answer is 10 or something like that. You have to learn why the answer was 10 or something similar. So it can be a tool in your toolbox, but it should not be replacing your brain. You are coming here to actually learn this information. You're going to hopefully use this information in your future. Chemistry is pretty awesome and I use it quite a lot. I'm an environmental engineer who uses more microbiology, but as an environmental engineer, whenever I'm trying to have my little microbes eat of some contaminants or waste in the world, I need to know exactly how much of that contaminant is there. I need to know what its properties are, how much energy is in it. There's a whole bunch of chemistry that I needed to know as an environmental engineer before I could actually do the environmental engineering work. And this is like the foundation for it. Hopefully at the end of this class, you should be able to talk a little bit more about how different types of atoms and molecules are going to determine different types of chemicals and their behaviors. You'll have some comfort using a lot of chemistry, mathematics, and like terms in the various units and like knows the stoichiometry. So that if we like breathe in oxygen and exhale carbon dioxide, we could balance that reaction. We could see how much carbon was in our body, all the sugars and things like that, because that carbon becomes that CO2. You should be able to do that stoichiometry and balance those equations. And I hope by the end of this class, you're able to strengthen your scientific communication skills, think a little bit more critically about how to solve chemistry problems, and just comfort in reading and interpreting graphs. Still a pretty basic course overall, but yeah, any questions? Cruising along, great, love it. How to learn this class. You're going to need to get your own lab notebook. It could just be any composition notebook or something like that. Just even a folder with a bunch of papers and stuff like that in it. Something that is concrete that you're bringing to class every single day so that you can take notes. I pretty much do all my notes handwritten on the board, or I'll use my tablet to actually write things down. But we are writing a lot of complex chemicals down. We're going to do chemical formulas and chemical equations. And that work is really hard to type out on a computer really fast. So it is a lot easier if you bring something where you are physically writing out those notes and keeping track of things. Also, handwriting has been shown to like give you a second method to like actually let things sink into your brain a lot better than just typing things out. So handwritten notes are way better. Pretty much every class, you should also bring your syllabus. Because if you looked at the back of it already, you will notice it has a periodic table. I've also got one over there. We've got a periodic table, and then on the very back, there is a couple other really handy informations from like Avogadro's number to some of the other lengths and measurements and units. There is quick information that you might have to use very, very frequently in this class on the back of your syllabus. So if you bring this to class, you've got a quick little cheat sheet on it. Otherwise, we have a land acknowledgement, which I didn't really rewrite it from my microbiology version of this, but if you want to find out more about what land we're on or where you came from, there's some really cool information at this Whose Land website to go to, as well as the Hampshire land acknowledgement. We've got Zoom recording. We're already actually recording this class. I pretty much record all of my classes so that it is available online, hopefully a day or two after class. I'm usually pretty good about putting them up. So if you want to go back and rewatch a lecture or something like that, you have the ability to do that. Zoom is also available if you are sick. So if you missed a class, you can go back and watch a recording or potentially watch it live from like your dorm room or something like that. You are strongly, strongly encouraged to be here in person for pretty much every class. If you start coming and trying to show up on Zoom all the time, we've got a problem and we'll have like a conversation about that. But because the experience is much, much better when you are here in class and in person. But should you need to come into class on Zoom, it is an option. It is there for us. But it's mostly just trying to record things so you can go back and watch stuff. We've got two calendars with two different lab assignment things. Welcome. Wherever you can also start merging onto that table if you'd like. However, it's best. So up here, we've got our lab calendar and schedule. We are going to start labs next week. So we'll start off with our basic safety and measurements where you're just really working with pretty much water and salt for the first lab of just how do we get to measuring things? How do we use different various analytical equipment in the chemistry lab? Then we'll start using Beer's law, which is a really fun equation that we'll get into where we get to just, we're going to find out how much food dye is in Gatorade. And they'll start working on a couple other things like trying to find out how much vinegar is in various fermented foods. We'll start working with some gray water stuff at the Kern to try and figure out how much nitrogen is in it. We'll do some water quality stuff. We'll learn how to use Excel spreadsheets. We're going to find out how much caffeine is in coffee cups and things like that. This doesn't actually have caffeine in it. This is like not real coffee, but yeah. And then at the end of the semester, you and whatever team you create, you're going to create a small chemistry project. It could be something really simple or however big or small you want, but you're going to have the last 3 weeks to work on a chemistry project of your choosing, whether it be I want to actually figure out how much caffeine is in a whole bunch of various things, or I don't know, I put down a couple different examples of what you could possibly do. If you wanted to try and get struvite extracted from the gray water system at the current, that would be a really fun thing to do. If you want to go and try and measure methane generation on the compost piles on the farm, that would be a really cool thing to do. So that is going to be a project of you and your choosing. You're going to work with your team to get some data points and write up a small report based on that. So that's what you're doing for lab. Every week, you're going to have a small lab report that you're going to do, and these are going to be rather simplistic, just questions. There'll be a couple pre-lab questions of just like, what do you think we have to do? Come up with a plan as a team for how you want to approach this lab. And then some post questions once you collect all of your data. You're going to turn in your lab reports or your lab notebook probably twice throughout the semester. And Ananda and I are going to go through and just make sure that you are keeping up with everything. But that's it for the lab side. Any questions about this? No? Cool. For the actual class today, we're just doing an introduction of stuff. Next week, we're going to start off with chemistry, matter, and measurements, and we'll start figuring out how do we actually measure some stuff in chemistry. You can go through all this on your own time. But we do have a review coming up right before our fall break. So this is going to be like our first exam-like thing for this, where you're going to show me that you've actually been mastering some of the first things in class. There will also be another review at the end of the course. Uh, yeah, this is pretty standard and typical. It's fun chemistry things. Um, your major assignments for the actual class half of this is going to be those two reviews, which are going to be, you will be allowed to bring 1 page of prepared notes to help you out through this, which again, AI can totally write you your own 1 page worth of notes and stuff like that, but how well you can actually synthesize that material, well, that's going to be up to you and your brain. Computers can't help you on that part. And then your other big project is towards the end of, or the second half of the semester, we're going to do social justice presentations where you're going to take some chemistry topic and tie it back to social justice. So we could talk about things like the chemicals of makeup and beauty products. You could talk about acid mine drainage and extraction techniques and how they impact like lower socioeconomic groups. You could talk about like the green chemistry movement and things like that and how people are trying to really improve or reduce the amount of waste that we have in chemistry and the amount of hazardous compounds that we build. So some small group presentation. Hopefully this presentation is with the group that is slightly different than your lab group, so you actually get to meet and chat with other people in the class. Yeah. And then for the minor assignments, every once in a while, there'll be a couple of check-in questions, which are just like small questionnaires in class. A lot of it is 1 or 2 problems and a check-in of just like, how are you doing? Are you doing okay as a human being? Making sure that you are keeping yourself above water because we're in some really incredibly challenging times. And then there will be pretty much weekly homework, which will just be a couple of problem sets. Almost all of those problem sets will be straight out of this textbook, which again, this textbook has been online for a while. You could probably Google half the answers in this anyways, but I need you to know what you're talking about. You can't just give me an answer on it. For the problem sets, I would prefer if you did those mostly handwritten again, because you have to like getting into the rhythm of drawing out your chemistry formulas or your different molecules and stuff like that. That is a really important skill. So please do them either on paper or if you've got like a tablet or something like that. But typing up things for complex chemistry stuff can be a real challenge. Any questions about the expectations for this course? We're at like the post lunch, so we're gonna take a nap this entire time. Cool. Otherwise, please go through all the syllabus. When you are done with this, I have my silly little pet policy. You are going to send me a picture of your pet or any of your plants and stuff like that. That will be your official acknowledgement that you have read through the syllabus. The actual pet policy is much more about service animals if you need those accommodations in class, but I don't think. The rest of this is just boilerplate stuff, accessibility. Nope. Accessibility, discrimination policy on campus. What else we have? We have, if there is ever an emergency on campus, this is the phone number that you need to call. If it's a really big emergency, then you just call 911 and they know like where on campus you are and whatnot. But this is for campus safety and well-being. Should we need them at any time, you should have this like number in your phone because it's really important. And then the last part of this is just all the useful little things in our class that we are going to constantly use and reference from this. Is there anything else I want to cover? Probably more things, but I forgot. So, any questions about the syllabus or expectations, any of the stuff? Yes. Good.
If I put in the notebook, can that be a separate notebook that,
Yeah,
or
so
can that be a notebook that I like mix in every subject, or does it have to be a notebook?
I don't know how fast we're going to review your notebook.
Okay,
So you will probably want to hand us something separate.
okay.
Yeah. You can just reuse it for all of your chemistry classes and keep it like, cause as like for multiple chemistry courses in the future. But I'm gonna say it should be its own notebook. Cause we are gonna try our best to turn that around, but can't guarantee anything. So with that said, Moodle, that's what I wanted to go over. Moodle really quick. So Moodle, pretty standard Moodle setup. All of our things that we do is going to be separated by each week. I will also put at the end, once I get a recording for this class, I'll put that up in this week's stuff. But Moodle is going to have all the information that you pretty much need at the end of each week, including like later today. You will probably get an email that will just say like a weekly recap of, it'll tell you 3 things that are really important. It'll tell you what we did. We went over the syllabus and we're going to do one basic intro activity. What are we working on? Hopefully you're reading through your syllabus and making sure that you're cool with everything on it. And then what are we going to do? Next week, we're going to be working on things, on basic measurements of chemistry, of chemicals and analyses. So that is the 3 things that every week I promise I will send you an email. It is going to be one big email that just says what we did, what are we working on, and what are we going to do so that you can keep up with everything else in class. Any questions about that? Cool. So with that said, we're going to do a fun little activity to try and get to know each other in the classroom. I'm going to have us break up into 6 different groups. And I have 6 little worksheets here that you and your group are going to spend some time together on. I want you, you're each going to get one of these things. As a group, you're going to get one thing. And I've got 2 types of chemistry disasters. I've got 2 types of agricultural chemistry things. And I've got 2 types of everyday chemistry things. But what I want you to do is focus on, if you were approached with this scenario, how would you possibly, what kind of things do you need to know? If you are trying to solve the Great Molasses Flood of 1919, which was in Boston, where 2.3 million gallons of molasses burst from a container and spread throughout a neighborhood, what kind of chemistry things do you think you might need to know trying to approach cleaning this up or dealing with that situation? So I've got these 6 scenarios. We've got East Palestine, we've got fertilizer application, we've got biodiesel production, cup of coffee, and medications because my dog had an upset stomach the other day. So, for the first one, disaster chemistry. Is anybody particularly excited about starting a group for the Great Molasses Flood? Great. You 2 are going to be in a group together. I would love for you 2 to introduce each other, tell each other your names, your pronouns, what are you studying here at Hampshire, and then start writing out an approach to this because we're going to talk about it all later on with the group. Who here is particularly interested in the East Palestine disaster? We got 1. Do you want to be in the group or do you want to like wait off? Okay, we got 2. You go. Cool. Yeah, y'all get the. How about fertilizer application? Think about here on the Hampshire farm. Got 1, 2, cool. All right, 1, 2, 3, 5. Together. Who's here is interested in possibly doing biodiesel production? Cool. For everyday chemistry, cup of coffee. No one wants a cup of coffee? You want Ava the dog? Lucy, you want? I don't want you to be by yourself. What do you do? Medication. You're okay. I'm gonna give you medication. If you are not in a group, what were you trying to pull up for medication? Okay.
We're all gonna.
You can do 1 mega for medication. That's fine. For real? I'm not. Together. What would you like? Yeah. Nobody wants to do a cup of coffee. Extraction efficiency. We're gonna do this lab later. If you got like I'm gonna give you a second sheet. Okay. What are I want to be
It's like real 400.
with fertilizer application. And introduce you to your teammate who Has a syllabus.
Ari?
You are.
I have forgotten.
No,
Okay. Good question.
If you both want your own sheet, I got one. I really think fair for part of it. And then.
Do you think?
It has some yogurt. What kind of process?
Oh, Burger King.
Why?
Do you want to know what the fuck I don't know.
Right, cause I know,
I know what she ate.
ooh, I don't like, just trying to get like, like, so. Wait, I'm not. When I write it like really. Oh, what do you? I did. You would probably.
Or yeah, like grade level before I dumped it.
Yeah, she was with us. I'm like,
Yeah.
I still think that. And it is right on how that relates.
Yeah, I've,
Yeah, it's, well, yeah, it's thicker than water, but when it. Maybe that's not matter, but. Ooh, dosage. Okay. Maybe all properties. Oh, measurements. Yeah, I guess I want to go back. How soil going to live. Yeah, like if it's like. Yeah, that's. I just. Yeah. Area.
yeah.
What? A lot of those. A lot of those. In fact, it was Harvard for a long time. Yeah.
What's the dog's?
Yeah, or how much actual, they have to apply to get. Yeah. Yeah. And if we apply, I think you know, like.
I don't forget that. What about the animal people? Let's go.
Yeah, animals.
What do you want to say?
We already say. What about that warm broth? That warm broth.
How
did you feel? That warm broth.
The temperature.
Yeah, what's the reading?
Yeah.
The temperature.
Like what, yeah, is there a method that is less likely to cause, you know, that's like more specific?
Right.
Yeah.
Exactly.
It's basically.
The whole field, yeah.
Like, what are we gonna do?
There's some things with the weather or temperature. Yeah, because that's not gonna be like.
What do you, that's why.
So like, you were saying temperature, right? And how's that?
Oh, well, last is soft. And it's 1993, so
But I'm here all.
they are like right on the curve and have a lot of water, but they don't. Have,
Don't know
like,
don't have the word for it, or like lack of or vitamin.
So we might need to know
Based
things
on-
like. It's
But
definitely.
these ones,
And it's
it
solid
would either
Oh,
just
it's
like
not-
until
well, you're-
it would just be
Like
like
some of the chemical
powers.
Yeah.
There's yeah, there's like I'm saying, if it's one next year over specific to like what
Got
you,
it.
what you do know already. If you don't know much, that's okay, like this is day one.
Yeah, no, like,
Yeah.
is there gonna be a negative? Yeah, more likely that, you know, worse outcome depending,
Yeah.
but you know, still the selection you.
Too many snacks.
And if it's.
But then what I wasn't ready for snacks. So
It's actually like we have to show.
Yeah, man.
dogs are not. Yeah. So we see.
What do you say?
I mean, they need to take
Throw that on. That's like the dog.
Size.
How old dog is?
Like color. Like the rain, toenail size.
Exactly how much
Like,
rain, if there's.
What else, like, why is it
rain,
important beyond just the difference?
Soil and then fertilizer.
So, when I'm hearing it, that when you're
like,
thinking about.
property
I'm sure that's gonna be besides
So like,
climate.
we already said.
Right, that was-
Yeah.
I mean, true.
I can't remember that I learned.
We're. This is the one.
Yeah, I was like,
Thing
there's
is,
so many
like,
terms that I
back
just,
then,
were like
it's
in the
not
back of my
really-
brain.
Yeah.
Yeah.
We're good at time to train them old, so.
Yeah.
That's because when you got active.
Yeah.
Cool.
Well, it's.
So I just don't, you know, I mean, what I know about this one, it's kind of correct.
Oh, yeah.
So I don't know, I just, we know it takes us.
Quickly, things gonna absorb the rest. Yeah.
But I.
Why are they, so why are they important?
Actually,
Kind of
and it's but it's smaller.
Okay, so in real life, she got into the more. I would say further one word.
Totally fine, actually.
Here's the time.
I don't think it's.
Yeah. And like that, the name for like using.
Because you're like putting out 10 bucks for water and those limits, and 10 bucks for a lot, that's very different.
Well, is it or is it afterwards?
Right,
It's not a new.
It's just, I don't know if there's.
No, not yet.
Context for this question.
Right.
So,
Absolutely.
and I just don't, I don't know that the variables even matter that much. Oh, you know, something like.
I don't know your name anymore.
Really?
I see him.
Here,
Right.
Oh, yeah, well, I feel like it's that we might
Makes sense.
have
Like,
something to
like,
faster.
I wonder if
The density and what.
Learn some of the things that we need.
So we-
So if you.
break one block somehow.
Yeah.
Like, yeah, but like that was really solving water outside, you can act like that moving it.
No, it's okay. You need to know what you ate first, and then the chemical components of the acid relation to the food that she ate. How those processes interact. And then we talked about like living cultures with that, like yogurt, again, like that might have a.
That's
And
right.
yeah, like allergies, that like what kind of reaction like they're like if allergic to something that you're going to feed her and then drop the yogurt. And then the makeup of the food and the natural chemicals of her stomach, how that's gonna interact, and then like temperature and broth, like what is it gonna be formed? Like what is that?
I'm with you on all those things are important. I'd love to like try.
I'm really
to more about like.
And we might,
Why?
then, wow, we're doing
Why
about.
the antidepressant side, why the things, there's something about like passing phase.
Where are you? Just like that.
What is it? What is it after?
Right.
Write that down, write it down.
Everything you know is fantastic, just try to drive it a little bit deeper. What you really have.
Reducing the amount of disarms. In terms of like the health of, because if you're right, because it's the health of
Okay.
communities, you know, like if it's literally just running off and then you're right drinking water.
Okay,
You know,
the one broth might die, yeah. I know you do, but what's your name?
That's a really good idea.
Yeah.
Or if it's already, you know, there's something in
That's the bad.
you know, like,
The bad.
yeah.
Like if she ate like poison, it would die like that.
Modern machinery, but not back then.
Her gut microbiome, yeah.
You're right, roll it.
Actually, if she has trouble getting her medication down.
Oh, it's January too, that fucking sucks. In No, you just screwed it over, you can't do
And
it.
also it might like impact the energy water. Yeah. They can't.
Clearly it wasn't,
Right.
but it didn't go very well.
Whether that will prevent their like.
I mean, the last fire, like, it really absorbed, like.
Yeah, I mean, they were able to get rid of it.
Putting them together.
The thing is, it was never like, never, yeah, all of it. Like, we got rid of a lot of it,
Like, but then I'm kind of.
Oh.
Isn't the whole like, isn't the whole building get like, isn't it like a while?
Probably.
So you just say like.
Whatever it's not.
Have you heard about the like?
And they're the same, so.
Oh, actually.
In 1919, I don't know. What that
Yeah, the tablet.
Yeah.
You're any kind of medication, trying to be. Well, not any, but like your college medication, like administered to the body. Like,
Wait.
you have like an IV or something. Right, going on your skin. You got all different measures of delivery. I mean, I don't think.
No,
like,
like,
it's a lot of time.
fertilizer.
Yeah, like,
I think it's like.
Big house.
I swear, They get.
I've never.
Are there dog pumps?
Surely there are.
There has to, you know.
Exactly, right?
So you have to know, so you have to know, so you have to know.
It's the broth.
Yeah, for sure.
I know, at the end, what's in the broth?
Yeah.
What's in the broth? What's in the broth?
It's like.
It changes, a lot of water. It's a lot of water in the broth.
Like, I got it.
Oh, like,
Yeah.
the whole broth.
And like, you don't have to blink it.
I'm trying to.
And they're done that. So good. Yeah.
Why is he
What's for salt level? Good idea, but like, salt level.
Oh, one other. What,
So it's like. It's not easy. I got this, red bill for like shipping and coming back. Under the. No, he was fine.
You do kind of. I just started fertilizer,
Yeah, or more effective,
Okay.
yeah.
It's really fucked up, but.
I think the timing is important, right? Like, when they have to have problems.
Take like another 5 minutes. What I would love for you to do is try to come up with like a good summary so that we can talk about this as a team.
We should summarize.
Summarize it.
Maybe someone should do it so they can do it on the back and we can have use the rest of
Write it down.
Okay.
We write on the back of this.
Yes, you are welcome to write on these.
Like,
Or yeah, if they're using, them, if they are using them, we would need to know to make sure
What
that
was thrown on?
there's no, the adverse, why is it happening? Yeah. What was more. And you know, sort of, does that increase the chance?
stabilize, so when you get negative, like it's also set up.
Okay, microbiome.
Remember that?
So they're doing, better to.
Okay. And just overall like potential makeups of those things in relation to the IE.
Oh, why it's important, yeah.
Well, like, I don't know, because is it for how we utilize? Yes. There's some
That is fair, so.
You don't want to lie. The homeostasis, literally the homeostasis, y'all were laughing. No, I meant that.
I'm smiling. I'm thrilled that you're going there. Great.
I literally want to know where you're going from these. How diverse is it?
So to restore it to like equilibrium, so you're going to say, you know that when you said it. Because I think I meant it wasn't like bring it back to where it's supposed to be. Like,
I think neutral and means like 7.
yeah. I don't want to twist the words.
Exactly.
Yeah, I know. Like, in my brain, I think. Something I do, which is why it's not.
What else do y'all think?
So then once we know that,
It's, oh, well, I mean, it's like.
Yeah.
Right.
what would be the most interesting technology
Compared to
to
something.
Yes, yeah,
Like closer and.
Like,
I'm guessing how many doesn't live with that. It's telling you
Right.
one of my chest.
yeah, the water also just.
Well, because, I mean, it's,
Oh, warm water.
I mean, if it's all like, it's like a lot is.
Oh, I think maybe like another cool thing I can put in is like, no, it'll raw and then like, relationship with temperature and dilution.
You know, if there's anything else on my station.
Really wanna make sure.
No, I don't say that.
What type
There is probably too late. I mean, if it was going further, but at this point. Oh, actually.
But also like something earlier, I guess, but it would help you know with the block like thing.
Like 2 more minutes, y'all.
You're right, yeah, I was, like I had thought, it's just coming out, but like, it's still after this, everywhere. It's still very well.
Right.
So I was like,
Again, I mean, guess what?
Bacon? Oh, you and Brandon.
yeah.
Right.
I know, Brandon went back to.
So, because they don't.
Right.
Yes.
Like,
You already said.
Slash J, slash
Already
J.
said.
No, you gotta know how to read.
Oh, after his.
My brain is like broken, it's like. For some reason. You're there.
Right, that's what I was saying.
Oh, okay. This is.
It's like, I don't know how to write any letters anymore.
Environmental costs for, you know, public safety. And hopefully, yeah, apparently there's a time, like the most, ratio. I'm so sorry. It's all. Like they're having. Yeah, this is a week. I know, but they don't have guys.
No, true, I did round.
Like I saw one sitting on top of a fridge.
Is that?
But you know what? That's what the phone on too.
If I can buy allergy.
I really didn't even.
Oh, you're a liar.
Yeah.
You didn't listen. You guys didn't actually get it. We lost like, you know, because it's just. Yeah. You tried to tell them on it. It's me and 5 minutes. No, say harvest. Slow.
January.
Yeah.
Yeah, be aware of the certain days. You'll be aware of like, we don't.
Yeah.
He's gone.
All right, team, let's bring it together. So we're going to start off with our first scenario. So the Great Molasses Flood, where 2.3 million gallons of molasses burst from a container and spread throughout a neighborhood in Boston. Team, tell us a little bit about what you think we need to possibly learn. What do we need to know?
So we looked at this both from a perspective of like control and cleaning it up. So we were kind of like, okay, there's fucking molasses everywhere, and there's already done a bunch of damage. But if we like start moving it somewhere, like we were thinking water, like how like we're looking at here, we want to know like how dense it is, so that and like also how much it is. So if this is gonna go like, for example, down the storm drains, we want to know um like how soluble is it, also how viscous is it? Like will this like continue to like flow through the storm drains? Will this clog everything? Like if we want to barricade something, like how strong does our barricade need to be, like based on how much weight this is pushing on like on that, like if we were putting up sandbags or something, but then also like given the weather, like it's happened in January. Yeah, it's been on January 15th, so it's like dead of winter. So we probably want to wait for like the day when it's like sunny and everything's kind of like the moss has kind of absorbed a lot of heat, hopefully making it more viscous. We probably also want to know how it behaves, like how its viscosity changes based on how much temperature, like or based on temperature it has, like current temperature. And then again, I think the most important point is like water solubility, like can we actually wash it away is kind of what we were thinking. And keep in mind, it's also 1919 at the point this happened, so we don't really have a lot of like the tools that we would now. So like water to dispose of this seems like the best strategy. Like fire hydrant, like wait till it's most viscous, and then make sure that we don't accidentally damage anything else while it's happening.
Cool. I heard a couple things that sounded really awesome and really good there, which was like talking about the density, the solubility, viscosity, specific heat, which is the amount of temperature needed to, or the amount of energy needed to raise the temperature by 1 degree. So if it's really, really cold outside, you might have to put in a lot of energy to try and get this to be less viscous and actually movable somewhere else. Yeah, the other thing that I would like to point out is how we refer to this, where this is what we're going to talk about a lot next week when we talk about units. But when we have units that are really, really large, we often try to simplify them where we might either round them up, we might use the appropriate amount of significant figures. But here we're talking about 2.3 million gallons. We don't need to know that it was 2.3875, whatever, like all these other running numbers worth of million gallons worth it. This is a reasonable assumption of it. And when we deal with things in chemistry, sometimes we're dealing with individual atoms that can be really, really, really small amounts of things, or you can have things that are really large, but having the appropriate units to actually quantify this problem is something that's really important for us. Anything else you want to add? Good. Cool. Awesome. Great job. Our next group, the East Palestine disaster in 2023. So here a freight truck exploded and fell off the rails. It poisoned a neighborhood and contaminated a bunch of things. Which team? You two. Talk us through it. What do we think we need to know?
Okay, sorry. So we thought that some things to know on state properties. We wanted to know the exact amount of hazardous material that had been spilled.
Okay.
Because depending on that, like, because we also realized that it was probably an organic compound, or at least it looked like one. And we were hoping that we could find another like chemical, perhaps even to neutralize it in some way, shape, or form.
Mm-hmm.
We were wondering if there would be any like harmful byproducts from that neutralization process. Because in the end, we would like to minimize the impact, like negative impacts on like the environment, people, agriculture, or like the people living there.
Mm-hmm.
We also discussed solubility, like if we could dilute it with that, like decrease the amount of harm being done. And also whether with that density as well and how it interacts with water, like depending on the properties that it has. We thought that we considered whether or not it would degrade naturally, assuming probably not. But if it does, like how long would that take? We considered, let's see, considered a lot. And also I think I might have said this already, but again, if it evaporates and any harmful by.
Cool.
We also considered whether or not it may be radioactive somehow. And if so, half-life, which also again just goes back to whether or not it degrades naturally or how long it takes to do so. And also thermochemistry, because the fact that there's a fire
Yeah.
in the image, you're wondering whether it was due to the combination of heat from like the derailment or and combined with the chemicals or just the derailment itself, and then we wondered if the materials were flammable perhaps.
Cool. That is really awesome. Yeah, I love all their considerations for like evaporation or partial pressure because we've got something that was presumably in a really heavily pressurized truck that is now all of a sudden spewing out. Is going to be changing from a liquid state into the gaseous state, possibly, and spreading throughout the town. You talked a lot about how it could possibly break down and degrade, where there might be some other chemicals we can add for an oxidation reduction, where we can change it from vinyl chloride into something else, usually just ethane. There's a microbe that can actually do that reaction, Dehalcopoides McCartyi, which I worked with as an undergrad. So, because vinyl chloride's a really weird one where we often use like perchlorate, which is found in a lot of older dry cleaners. We'll use it as like an industrial degreaser. And that perchlorate, every time it breaks down, it releases an extra little piece of its chlorines. So it starts off with fluorochlorines, then it becomes trichloro, then dichloro, ethane, and then vinyl chloride. Vinyl chloride is the most poisonous of them, so it becomes worse and worse and worse. And then all of a sudden, once you lose that last chlorine, all of a sudden it's pretty harmless. So yeah, it's really cool. Benzene's also like another carcinogen. Every time you go to the gas station, you smell that like kind of sweet smell. That's benzene. It's cancerous. Good times. Yeah. Fertilizer application. Do we have a group on this one? Was this one? Yes, we did. Awesome. Tell us a little bit about this.
Yeah, so sort of begin wanting to know like what crop is gonna, are we applying fertilizer to? What's like, when are we applying fertilizer to it? Like we know it's in the spring, but like when in the spring, sort of near the beginning of the growth of the crop? Is it in the middle? Is it gonna be like multiple times during the growth of the crop? And then hopefully if we knew which crop, we would know which fertilizer we're gonna be applying. And then what's the solubility of the fertilizer? What's the concentration of the fertilizer? How is it gonna be applied? Because that could determine like sort of, I guess, like how much like at risk it is of sort of being included in runoff. What is precipitation sort of predicted for the spring? And like, do we have any knowledge of like when heavy rainfall might be occurring? Can we time the application of fertilizer sort of to like try to minimize the risk of runoff? And then just like what other like pesticides or other like stuff is being added to the crop? Yeah, just so we can know like if there's going to be negative environmental effects, if there is runoff, and so we can try to manage that or like, yeah.
Cool. That was awesome. So just to recap that one, you talked a lot about like the concentration, the amount that you're going to have. You also want to know some of the functional groups. So whether or not that has a lot of nitrogen groups or phosphorus groups, because you might want to put different things on different crops. You need to know the solubility so that hopefully the first rain, if you have something that is less soluble, it will actually stay on the farm in the field and not just get swept up and away. And then one of the things that we've been working on, like with crops and like designing new fertilizers, is changing the reaction rate. So you have like those newer slow release fertilizers, and all they're doing is trying to change the reaction rate so that it is a little bit more stable, so that there is likely that part of it might only degrade really quickly, and you can get one nitrogen today, and then we'll hold on to this one bond that is much stronger, and you'll get some nitrogen later on down the road. So changing those reaction rates based on which functional group can be part of the game for it. Awesome, good job. We have one person who's working on our biodiesel production. And Timmy, you want to go for it?
form our product that as.
Mhm.
because Glycerin can be dissolved in water, so, biodiesel aqueous, then that's all that's together, separate now.
Cool.
Other thing we want to keep in mind is what's happening during reaction, are we getting a lot of gas? Are we getting anything that could cause problems to the machine?
Cool.
Another thing is what can be done to reduce the amount of waste, like. Can we dry people to keep glycerin?
You can make soap.
Part of the equation. Safety,
Safety concerns? Yeah, I will love some safety concerns.
great, but it blows up, but it's just clear. Can't use that.
Yeah, that's also really awesome. I love that you're thinking about the state of the matter. You were talking about the thermodynamics of the reaction. So some reactions, they will make a lot of heat when they're going through those reactions. Some of them will also like take away heat and it'll become really cool. Think about like when you've got one of those little air compressor cans or whatever, and you start squeezing that air out for too long, all of a sudden it becomes really, really cold because you've changed state that it was in, because it went from a really compressed state. Cool. State of matter, we already talked about. But yeah, when you do biodiesel, you can make a bunch of soap. It's really fun. I would actually wish chemistry or a cup of coffee. Nobody wanted to talk about this one. Things that I like about a cup of coffee one, because we're going to also do this like later on in class. But there's like yield and extraction efficiency. So we have all of our caffeine in our cup of coffee that is going to be initially on a solid that is going to be like their beans, and we're going to try and put it into a liquid phase. So we need to know some of the solubility of that. We need to know how much caffeine was originally in those beans and how much is going to be in that cup of coffee. There's some stuff with like aromatics and like oils and stuff like that we could have gotten into, but that's all cool. We'll jump to saving my dog. Take it away, team.
Oh, I'm taking it away.
Yeah, go in.
I must. So we wanted to know, first of all, what did Ava eat to upset her stomach? What was thrown off balance to actually be the problem? Which, involved the symptoms and her original pH of her stomach, her original gut microbiome, her natural state of her gut, so that like what are we trying to achieve? We have to know also based on her size and based on how off things are, we then adjust dosage of something like an antacid or the yogurt or the broth. We want to make sure we account for any allergies, which is kind of chem if you think about it really hard.
I'm trying to think about it really hard.
Everything is a chemical,
Everything is a chemical,
so
right?
think about that too.
I'm trying to think of like a topic that it falls into, and
Allergies.
Allergies.
Allergy topic.
allergies is not unit 5 of your book,
I
unfortunately.
just took molecular. Super relevant allergies.
If you give me a chemical term, I will put it up there.
Chemical term. What do you mean?
I don't know enough about allergies to answer this question,
It
unfortunately.
involves your immune system,
Cool, great.
inflammation,
Cool,
which
that
can
is,
change things. It can change what your cells excrete, and that can change the acidity and stuff too.
okay, I'll keep that under pH for now, but,
Okay.
and pH and homeostasis of your body.
We
I'm here
talked
for it.
about, the significance maybe of the temperature of the we're giving her, and also the like water content. So, depending on what kind of, like, for example, what kind of broth, how much of that is water, how, like, what's actually in the broth that's doing the thing that would change for us at.
Yeah.
We talked about sodium level,
Cool.
super important in your body, and calcium and potassium. And some other things too, chlorine,
Cool. I'll put that under as conductivity.
yeah,
Ooh.
good point.
Yeah, great.
And that's, I think, she,
Awesome.
Yeah.
No, I think you did a really good job, like, yeah. And so pretty much throughout the course, we are gonna be hitting on pretty much all these topics in some small amount. For some of the things like conductivity, that's usually more Gen Chem 2 later on. But we are definitely gonna be doing a lot of work with various temperatures, concentration, we're gonna have to become familiar with. I hope you're all reasonably comfortable with some of your math skills, because there'll be lots of simple math, but like it's a lot of algebra that we're going to be doing. It's not going to be like complex calculus that we're up to. But we will be doing quite a bit of math, especially when we try to figure out something like what is the concentration or the dose that we would actually give for my dog or for this experiment? How do we go from something that's like a really concentrated stock solution of something to something that is going to be more dilute? How do we accurately measure those things? So yeah, they'll hit it home. Cool. I think it's gonna be a really fun class. And that's really all I've got for us today. So thank y'all for coming, and I will see you next Monday when we start talking more about various ways to measure things. Next week is gonna be all lots of simple algebra math.
It's really hard.
Yeah, like right there.
Yeah, it's a good fall.
Thanks for saying.
You can keep it.
What? Oh.